Okay, so this is going to be a talk on TensorFlow Datasets. Just to be warned, I'm going to be jumping backwards and forwards between web pages and PowerPoint, so I want to make this as interesting as possible, so just don't want to do straight slides. So my name's Godfrey Nolan. I work for a company called Reese LLC, which is based in Troy, Michigan, and we do mobile and web development. And basically my interest in TensorFlow comes from, we do a lot of mobile apps for drones, and we're really trying to push the envelope a bit to see if we can do some object detection using drones. So I've been working with drones for probably about 4 or 5 years now, and with TensorFlow for 2 or 3 years. And data sets interest me because when I started out, I was, there's lots of Hello World apps out there, TensorFlow apps, and what I was trying to do was figure out what the next steps are, and data sets kind of seem to solve that problem. So I thought if I had that problem, other people probably have it too. So that's why I want to talk about data sets today. So there I am. I'm founder and president of Reese LLC. Been around for 20 years, about 40 people. I've written 6 books on security and Android and iPhone development. And I'm also an adjunct professor at Saginaw Valley State University, where I teach in the fall, and then U of D Mercy, where I teach in the winter term. Both of them on Android development. Okay, so this is what you would normally think of when we talk about a Hello World app for TensorFlow. It's probably worth talking a little bit about what TensorFlow really is, because if you haven't done much TensorFlow in the past, it's not that obvious. So basically what it is a framework that sits on top of lots of different neural networks. So back in the 90s, if you wanted to do, the 1990s, if you wanted to do any AI or machine learning, you basically had to roll your own backpropagation neural network to do any predictions. From personal experience, I can say it wasn't impossible, but it definitely took a while. So these days, it's much simpler. You can call any number of machine learning models from frameworks such as TensorFlow or PyTorch. They sit on top of the latest and greatest neural network, and that's great too as well, so they get updated all the time. And they allow you to easily train your models. So this example is basically what we're trying to do is predict the output for y equals 3x plus 1. So if x equals 1, then y should be 4. So we're going to use a neural network here to predict what that is. We import our TensorFlow, we import NumPy, we set it up as sequential. We say that it's going to have just one layer of neural networks, so you can have multiple layers, and the input shape is 1. We set up what our optimizer is and our loss, and I'll talk about it a little bit in a second. And then we have our input data that we're going to use to train the network. So 1, 2, 3, 4, 5, 6, x and y. And then what we do is we try to get this to fit over 500 epochs. So basically what it does is it does 500 training sessions. And then when all of that is finished, what it'll do is it'll try to predict what 10 would be using our model, and it comes out as 31.0025749. So it's not exact, but it's pretty close. So our margin of error is very small when it comes to this, and it's a really simple model. So we've basically given it 6 inputs. If we gave it more inputs, we could probably make it better. If we gave it not just one layer, but gave it multiple layers, then it might work better too as well. But this is if you've done any TensorFlow, I'm sure you've come across this. The other example that people see is the MNIST one as well. So let's go and have a look. If we go to, there is a code lab, which is what Google provides. So this is a basic thing for what you want to do if you want to run this yourself. What is ML? We're going to create our first model. The only thing that I really wanted to point out here was that the loss in the optimizer. So our SGD stands for stochastic gradient descent. And basically that's what we're going to use, and our loss function is using the mean squared error to see what our accuracy is. So if we go to the actual code itself, to the this is Colab, not to be confused with CodeLab. When we run through it all, we can find that we get a loss of 0.0698, so it's pretty close. Okay, so the URL is in the resources for all of these if you want to check any of these out. So, okay, so what happened then was I found myself in a situation where, okay, I understand what a low world is. Now what I want to do is I want to move to the next step. So one of the things that when I was searching around, I could see that the workflow for TensorFlow was basically you load, train, and test the data. So what we did in the previous example is that we loaded the x and y's and trained it using our model, a very simple model, and then we tested because we did a prediction. So it's pretty simple. But I'm mostly interested in image classification and object detection, as we do, like I said, a lot of work on drones. So and then we typically deploy our model. So deploy isn't in here, but deploy is another step where you would deploy it as a as an API. In our case, what we do is deploy the model as a TensorFlow Lite file, and it's sitting on an Android phone or an iPhone. So a few years ago, we created an app that counts sheep, and we also did one that counts cattle from a DJI or parrot drone. And I quickly ran into the problem, which is the first thing that you run into when you use object detection, is that you have to label your data. So we went through all sorts of ways of trying to find people who would take drone footage of sheep. There was very specific things that we wanted to do, so it would have to be taken from straight above the sheep. It would have to be taken from a certain height, so it'd be consistent. And then we found the issue that we had: if you had lots of sheep, we had to label them. So basically, labeling means that you draw a box around each object that you want to detect, and you use this to train your network, so that the drone can essentially predict what object if the object that it's looking at is a sheep or not. But that's kind of expensive. So first of all, we had to pay somebody to fly numerous times, because you get lots of different lighting conditions. We had people flying in South Africa, we had people flying in Australia, we had people flying in Ireland, where I'm from. People in England were doing this. We had people in Denmark, Greenland. So we've had people express huge interest, and lots of people have been very helpful to us, and they've given us lots of different data. And but you have lots of different data, then you got to label it. So labeling means that you take the video, you chop it into images, and then each of the different images, somebody has to draw the box around each of the objects that you're trying to predict. So, you could have 9 or 10 sheep, and trying to get people to do that in a consistent way. There are websites out there like The Hive, or you can do it with Amazon Mechanical Turk, or if you could just find somebody to do it. We tried it with interns, but that didn't work. You got to find somebody who really wants to do this and is used to doing it, because it's a very laborious task, and unless you've got the right mindset to do it, it will literally drive you crazy. So it can cost about $1 an image, sometimes less, sometimes more, depending on how many objects you're trying to detect. So that's not, if I'm trying to learn something, that's a really expensive way. So I'm going to need 5,000 or 10,000 images at $1 an image. That's an expensive pastime. So what do we do to solve that problem? Well, basically, when I ran into TensorFlow Datasets, that really solved my labeling problem by providing a simple to use loading mechanism. When I first looked at it, there was 30 or 40. There's like 224 at the moment. I'm sure it's growing all the time. So assuming that your use case is covered by one of the datasets, and I got to own up, the cattle and the sheep are not part of the datasets. Not yet anyway. But if there's things in there that you're trying to learn on, so if you're trying to learn on flowers, or if you're trying to learn on specific type of flowers, or whether it's a cat or a dog, there are lots of data sets out there, and we'll talk about them in a second. So it's basically, TensorFlow is a front end to the neural networks, and TensorFlow Datasets is a front end to all the datasets that are out there. So they're not typically Google datasets. They're Google. They are public research datasets, mostly from universities, that have been out there for a number of years, and they're getting updated on a semi-regular basis. But basically, it just makes your life easier because TensorFlow Datasets gives you a way to get at the dataset so that you don't have to write any custom code. That's one of the things that you run into over and over again, is if you're trying to play around with lots of these different data sets, then you're writing lots of different Python code to make sure that you're loading it the right form. TDFS, TFDS, TensorFlow Datasets, is just a great way for you to be able to have a simple way to load them, and it's a consistent way. So basically, it's standard no matter what data set you're trying to look at. It's always going to be loaded in the same way, and we'll talk about that a little bit in a second too as well. And then, so simplicity, we talked about that. The performance, it follows best practices, and it can achieve state-of-the-art speed. So basically, that's really the next part of what you're doing in your training pipeline. So basically, it's going to download the data and it's going to set it up for you to be successful. It's reproducible, so all users get the same examples in the same order, but not only that, you get the same examples in the same order. So when you're trying to do it 3 or 4 times in a row, or if you come back to it in 6 months, it's going to give you the same data. It may give you an extended data set because it might have been updated, but you can pretty much guarantee that you'll be able to load it in the same way. And if you really want to, then there are parameters in there to give you pretty fine-grained control on what you're trying to do. Okay, so TensorFlow datasets have something for everybody. I'm mostly interested, like I said, in image classifications because of what we're trying to do in mobile apps and object detection for the drones. Why are we trying to do this? Well, it's easy to use, it's consistent, everything is collected together in one place, or rather one command, and there's typically the sample code to show you how to load and train the data. They're by and large not Google datasets, although Lawrence Moroney, if anybody knows about any of the Coursera courses, he's done a couple of datasets such as human versus horses. And there's a couple other ones in there too as well that come from Google, but mostly they're public research datasets. Format is always the same, which makes it really easy to load into a TensorFlow notebook. So rather than having to figure out how to download and import it each time. And then there's 224 at the moment. It's growing all the time. And then there's also a mechanism to add your own data set if you want to. So they're separated into categories. We have audio, image classification, object detection, question answering, structured, summarization, text. We'll talk about the text in a bit. So we're going to look at a Yelp example, but that's really what the breakout is. And then we have video. So in object detection, we have not only the standard objects that you'd expect, such as human or horse, or you'd also have the videos. You have objects that are used in automated driving. Okay, I want to show some of the data sets just to show what it looks like. So if we go to okay, you can see that we have a catalog here. Our catalog is set up into what we already saw there. If we go to the hello world of all this, I would say that has to be the MNIST. Oops. It's not in text, it's image classification, of course. So MNIST, what that is, we can see here we go to the homepage. So if we go to the homepage for MNIST, assuming it comes up in time. It is the handwriting data set. So it's used by the digits that are used by I think it comes from originally from the Postal Service. Okay, so this is a classic example about why you want to use TensorFlow datasets. So the homepage for MNIST is slow. So if you're downloading from that, it's going to take a while. There's a lot of caching that goes on with Google, so that you don't have to worry about it too much. So the MNIST database of handwritten digits available from this page is a training set of 60,000 examples, test set of 10,000 examples. It is a subset of the larger set available for NIST, and basically it's the digits that you would use to train your neural network to recognize some handwriting. We also have, if we go under the object detection ones, the ones that we tend to use for object detection would be the COCO. COCO is the Common Object Context, and it's from Microsoft, although there's lots of other sponsors now too as well. So it's a large-scale object detection, segmentation, and captioning database, and it's already labeled. So we can use that to either train our database or pre-train our database, so we can use it for something else. But we use that for the cattle counter and the sheep counter. And then the other one that I want to show you in text is the Yelp one. So let's go back to that. So we're going to use that too as well. So the Yelp review, so it's 560,000 training samples and 38,000 for testing. So basically, you have a review and it tells you how positive or negative it was. And then what you're going to do after that is that we want to make sure that we can use our testing, one of the elements of, or all of the elements of our 38,000 testing sample to make sure that our model is trained so that it's recognizing a positive or a negative review. Okay, so how do you load it? So if we want to actually load the database, we use the command tfds.load. In this case, we're loading the MNIST, so that's just one of the unique 224 data sets. We're going to split it, so which split to read? In this case, we're just going to pull the training part of the database, the 560,000. We're going to shuffle the files. We're going to shuffle the cards in the deck. And there's lots of other things we can do. We can specify where it's going to go. We're going to do this within Colab, within our own Colab notebook. We can tell it where we want it to put it. We can download the metadata as well if we say with info equals true. And also we can just run the command and not download anything if we don't want to. This is another command that we're going to use for the Yelp polarity reviews that we just looked at. So in this case, we're taking out two sets of the training data, and we're putting in train data, validation data, and then we have test data. So we have 3 arrays that we're putting it into, and there is no custom code. There's no hacks to get at the data set. The databases, the public databases, because they're mostly from universities, they do have a tendency to go offline from time to time, which can be really annoying if you're trying to do a demo. And speaking from personal experience again, and by and large with the TFDS, you don't seem to have that problem anywhere near as much. We'll return to the Yelp dataset later when we do our Colab demo. Just look at some of the image classifications. So we have Caltech birds. So we have birds from Caltech University. We have cats versus dogs. We have cars. We have horses or humans. That's the Lawrence Moroney one. We have the Stanford dogs. We have the TensorFlow flowers database data set, and we have rock paper scissors. That's another Lawrence Moroney. If you want to write an app to do rock paper scissors, we do that a lot as part of one of the assignments that we give the students to see if they can get rock paper scissors working in an Android app. The TensorFlow Datasets. So we talked about COCO, which is the common object and context. Kitty is for autonomous driving. VOC is lots and lots of different. I think that's what it is here. Lots of different objects, people, cars, and they're all classified so that you can use that to, and labeled as, you can use that to train your data set. Waymo is for automated driving, and then the wider face is for facial expressions. So you could, think about using that for an app for somebody who maybe has issues with recognizing whether people are happy or sad, in the autism sphere. So maybe we could use something for that. So each data set also has metadata, associated metadata. You don't get everything, but typically what you do is you get a description of what it is. You get the dataset homepage, download size, example code, and example images. We should have a look at a couple just to show you what that is. So, for example, let's go back here again. Let us go to the. See if we do the Caltech birds. I don't know if that has any. So this tells you where it comes from. It tells you what size it is, 1.1 gigs. We have image labels. Do we have any examples? No examples in this. Let's have a look at the cars. Yeah, and then we have some examples of the cars. So it tells you what type of car it is: Volvo, Suzuki, Hummer, Plymouth, Neon. So you get the general idea. It tells you who the people are who are responsible for this. It tells you, how many you've got, over 16,000 images and 196 classes of cars, what the split is, and how they're set up, the make, model, and year. Okay, I want to go through a collab now. So we have here, we're going to look at Yelp again, and so the runtime has been disconnected. So I want to reconnect to it. Okay, so I want to do a few things here and show you. So you can see that it's connecting up here. You can see that we have our RAM and disk space. I'm going to go to runtime and change the runtime type, and it's actually, I've set it to GPU and to high RAM. Just make sure that's working so it gets a bit faster. If you sign up for Google Colab, and I don't work for Google, so I don't have any skin in the game here, but basically it will, for $10, it will give you guaranteed access to GPUs, and you also get access to TPUs. I'm mostly interested in the GPUs just for the stuff that I do, and that will speed up your training. In the past, what we did was, I'm going to run this because it's going to take a few minutes, so I'm just going to run all commands and start it again. So in the past, what's happened is that you have, it takes a while for training to run. We used to do it on the GCP, the Google Cloud Platform. That was kind of problematic because it basically took a while for the configuration to work, and all that we need to do for Colab is we just need to go to the URL colabresearch.google, sign in, and start writing code, and you can use some of the code that's there from before. I'll show you what's happening right now. So we have it's downloading the Yelp database, so it's telling you what it's doing. This is going to probably take a couple of minutes. Let's see what the size is. So unknown size, but it's got 560,000 reviews, so it's big enough. Okay, let's go back to where we were. Okay, while that's running, okay, so it's downloaded now, and now it's basically indexing the files, and it's going to put them over here. So there are lots of things that are going on the outside over here that might not make sense to you. I want to create a new section. Don't want to do that. Let's get rid of that. Let's get rid of that too. So hopefully I haven't messed anything up there. If you want to search for something, if you want to add a code snippet. But here I think is interesting. So what this is this is I'm assuming a Linux machine that's sitting up there in the cloud, and here are all the different folders. So we can do a pwd to see where we are. Probably somewhere in there. Okay, so now it's shuffling and writing the objects to root TensorFlow Datasets, Yelp popularity reviews. So let's see where that is. So we have root, TensorFlow Datasets, Yelp popularity reviews, plain text, and the version 010. It tells me how much space I have. I think if you don't use Colab Pro, you just get 30 gigs. Either that or it's just gone up recently. And what's it doing now? Well, it's starting the training. So the training is going to take a while. It's not going to be as long as it would have been if we didn't do the GPU, but it's certainly going to take a few seconds, a few minutes. If you want to download each of these different files, then you can download the data to see what it is. And in a few minutes it'll download that as well. I think I already have a copy locally. So you know it's in a TF record format, but that's basically what you're doing. Okay. It's got 2 epochs in this case. We've just asked it to do 5 epochs, so we're not doing anywhere near the 500. Because that would of course take forever. Okay, let's let that run. And let's go back to our notes and then we can return to it in a second. Okay, so yep, so we're going to skip ahead to the next slide while that's running. Talk a bit about Colab. So much simpler than the Google Cloud Platform. You could, in the past we have done, spent days trying to get the GCP configured to make sure that it would work with object detection. It's just so much easier, and image classification. It's so much easier to do this with the Colab and Colab Pro. Colab Pro gives you access to GPU and TPUs for $10 a month. That's in the US. I don't know what it is in Canada. You can also, with Colab, mount on Google Drive. So if you want to save any of the Jupyter notebooks, you can save them locally. If you want to mount some space, you can mount that to the file storage that I showed you. So if you run out of space for whatever reason, you can mount more space. We already showed you where everything lives. Let's go back to see if it's run yet. Not quite there. Okay, let's continue. So originally I started off as a mech eng when I went to college in Dublin, and I don't, it's a long time since I've done anything of that, but because of my training, I think I always tend to the practical rather than the theoretical. So over the summer, a couple of our interns turned some of the TFDS datasets into real apps, and we have 4 of them that I show you here, and the link is in the resources, but you can basically find them under the RESA apps in Google Play. There's doggy in the window, there's IdentiPlant, there's a food classifier, and there is a flower classifier. So the doggy in the window is using the Stanford Dogs dataset. Let me show you what that looks like. Is that run yet? Well, let's just wait to see what happens. So it'll be done in a second or two. Most people will quickly sign up for the Google Colab because this really does take quite some time. So there was 75 out of 75 in 2 seconds. The loss was 0.188, and the accuracy was 92%. So we got just over 92% accuracy in our predictions. Okay, let's go back over here again. We talk about doggy in the window. These apps were done by interns over the summer. Basically what I asked them to do was to just take the data sets and turn them into something that somebody could use. So these apps exist in Google Play if you want to go and download them for your phone. This one is using the dogs data set. You can upload your own picture of your dog. So if you want to do that, it'll tell you what kind of dog you have, or it'll predict what type of dog you have. The other thing that we did here is all of the code that we have for all of the different types of doggy in the window, and this is taken from the data set. So the Stanford dogs data set. These are all the dogs that it's going to recognize. I also wanted to help other people get a little bit further, because I'm still thinking that there's not a huge amount of information out there on these sort of things. So we have a GitHub repo, the GitHub repo, which you can get to from here. So basically, if you look at the app, it'll give you some information, but it also gives you some information on how we put this together. So we took the code and put this out on our GitHub repo. So we have the notebook file. We have the Kotlin code if you want to see how to add a TensorFlow Lite model to your own Android app. And we have 4 examples, so I'm hoping that will help people get going. What else do we have? We have let's go back again. I want to talk about the identity plants. We have the identity plant. And this one doesn't use a TFDS database. This one actually uses a plant village data set. And we also talk about this. It's got some of the, whether it's the leaves that you show from, or the leaves that we're using to test, have they got certain diseases? And then if we want to upload our own leaf, so just took a picture in the back garden. So this one is tomato, potentially has some blight, and then it talks about what the different types of leaves it's going to recognize. The point I'm trying to make there is that basically you don't just have to use TFDS. There's lots of other things you can use too as well. This is a food classifier. This is using the Food 101 dataset. This is one of the Google datasets, and train this, and it recognizes baklava and dami. Hamburgers, upload your own thing to see if it can recognize what it is. You get the general gist. There's a pattern evolving here, isn't there? And then the last one is the flower classifier. But all of these, we basically give away the code. So if you want to see, this is using the Oxford flower dataset. It is actually coming from TFDS, but that's just the link to the code itself. So yet again, if you want to go and play with this, download it. There are other data sets, so not everything's in TFDS, so you might want to start looking elsewhere. So 2 of the places, that would be Kaggle and AI Crowd. But many of these are moving into TFDS. I've seen lots of Kaggle stuff move there recently. You might want to still look elsewhere, or just by doing a search on Google can find lots of university data sets too as well, if you can't find what you want in TFDS. So future plans, we're planning on doing some more apps early in the new year. We're also looking for Canadian interns this time around. If anyone knows anybody who might be interested, we're looking at doing some snakes, poisonous snakes. Want to see if we can write an app to tell if a snake is poisonous or not. Mushrooms, we want to see if we can detect an app if a mushroom is going to make you sick or not. Reason I have bad data in there is because there's a Danish app that does this already. It detects if a mushroom is going to make you sick or poison you. The app uses crowdsourcing to get lots of people to upload their own mushrooms. There are a couple of issues with this. The fauna that we get in the app is Northern European, so it doesn't really apply to North America. Mostly different types of fauna, but there's also a ton of bad data in there. So they're crowdsourcing to get people to upload lots of pictures of their own mushrooms, and there's no quality in the back end. So unfortunately, there's lots and lots of data that's nothing to do with mushrooms. Spiders, want to see if a spider is a brown recluse or not. So as you can see, I have lots of problems with poisonous things. Maybe I should add quicksand to the list here, but that's the plan for the next 3 apps that we'll probably throw out onto Google Play, and try to do one for the iPhone too as well. And then TensorFlow 2, the object detection API, is recently upgraded with support for TF2. And we want to redo our cattle and sheep counters to upload that data into TFDS so we can allow other people to use the labeled cattle and sheep. They're just sitting there in a GitHub repo, so it'd be nice if we could give access to other people, and then hopefully get people to collaborate it onto as well. Okay, a bunch of resources, so the datasets, the code lab that I showed, 2 courses, the Lawrence Moroney courses, which I really liked, which are the introduction to TensorFlow, and then using TensorFlow Lite, the device-based models TensorFlow, a link to our Reese LLC apps on Google Play, so you can see the 4 apps that we showed, where the data sets are on GitHub, so lots more info there, and then a very simple collab to show you how to do the data set and to pull information in, and then the last one is where I borrowed the Yelp reviews. Okay, thank you. That's it. If anybody wants to contact me, feel free to reach out at godfrey@reese.com. Okay, so I know it's only 35 minutes.